We've been focusing a lot on identification of a solution, identifying the strong, weak, and the non-electrolytes. But all of these topics are based off of the identification of solution, but we never talked about how much concentration of these solutions there are. And so we brought in the topic of quantifying solution through concentration utilizing molarity and also concentration utilizing pH for acid and bases. This video will focus mainly on that acid and base, but not in the form of pH, but what will happen if the two solution, acidic and basic solution, combine together. What will happen, and in addition, how much of the product might form. And that falls in the category of the acid-base stoichiometry. Let's dive in. So we're going to go ahead and predict the products of acid and base reaction. Whenever we have an acid and a base, when they combine together, we say this is a neutralization reaction. That's because it's going to form a neutral compound. For example, if you look over here, the hydrochloric acid and sodium hydroxide, which is the base, they combine together to form salt, NaCl, and H2O. You see that the H2O is a neutral compound. Therefore, we can consider acid and base as a neutralization reaction. Here's another example. Acid and base, hydrochloric acid with now potassium hydroxide forming KCl and H2O. Note that the salt here is labeled as NaCl and KCl. Salt doesn't necessarily always be sodium chloride, but it could be anything with ionic compound that is soluble. Ionic compound meaning something with a metal and a nonmetal. K is a metal and Cl is a nonmetal. So this is considered to be a salt. And you oftentimes will see water, but not always the case. But for this particular introductory chemistry course, I think water would suffice. Now note something here that I have used the Bronsted-Lowry acid and base definition in order to identify the acid and base. For acid, it's a compound that donates, gives the H. So if you look over here, the hydrochloric acid, it gave the H to the base. And therefore, this OH right here became water because it combined these two together. That's HOH, but we don't really use HOH for water, but we rewrite it as H2O. And the base is a compound that accepts the H. So this OH right here has accepted that H, hence why this is a base. Let's look at the next example. This H has been donated, and then it has given it to the OH, and so that one is the base. So that H gets donated, combines with the OH, forming again HOH, and that is rewritten as H2O. Now, I will go further into details how to predict the products if you have just the reactant. So here is an example. I have a sulfuric acid and lithium hydroxide. Can you first identify which one might be the acid and which one might be the base? Yeah, this one is, I might have just said sulfuric acid. This is H2SO4. You can see that this is the acid, and that's because the H is in the front, okay? So that's a big identification, which always isn't the case, but this one is. And then you see the lithium hydroxide. This lithium hydroxide, the hydroxide having that hydroxide really indicates that one is the base. Also, if you look in your reference sheet, it's probably in one of the lists of the strong acid and strong base. Now let's go into what's going to happen here. Now note over here it says aqueous on both sides. aqueous means that this solution, this acidic solution, is actually in water, and they're not in H2SO4 form, but in an ionic form. Same for lithium hydroxide. They're not exactly in this form, but rather they're in that split ionic form. And this is what I mean. So if in a container, realistically, they say this is water, beaker filled with water, and it has sulfuric acid in it. And this has H pluses, hydrogen ion, and SO4 sulfate. Now it's every 2 hydrogen for sulfate. That's why I have drawn 2 for every 1 sulfate. For lithium hydroxide, hydroxide remains together. You don't have a O and an H splitting off. Hydroxide is a polyatomic ion, so they stay intact. So OH minus, and this is lithium plus, and this is in water. Okay. So this is hanging around in water, and this is hanging out in water, and that's what it means by aqueous. It doesn't show in this molecular equation, but that's what's really happening. Well, we're going to combine these two, okay? So we have another container where it's going to allow these liquid to flow in together in this container. I mean, you could have just poured it in like this, but let's say it were to come together. Then we have these coming in together, right? Well, they're coming in. H pluses are coming in from this side, and so is sulfate, and lithium is coming on this side, and so is hydroxide. Okay? Well, what's going to happen is the hydroxide, or the negatively charged component, which is the hydroxide, will naturally attract the positive from the other guy, which is the H. So I'm going to go ahead and rewrite this. Let me get a different color, and to indicate these two are coming together to form HOH. And these two, the leftover, will come together to form LiSO4. Okay, and this is Li2SO4, since you need 2 lithium for every sulfate. And you may say, well, I only see 1 lithium here, and that's because I didn't draw more lithium. I need to, but it's Li2SO4, and that is because lithium has positive 1 charge, and sulfate has positive 2, and you need 2 positives to cancel out the 2 negatives. So hence why 2 lithium. So HOH, I'm going to remain it as like this. I know it's H2O, right? We have talked about that, but I'm going to leave it like this for now so that we can have a better understanding where the H is coming from and the OH coming from for now, and then we'll rewrite it. So my prediction in the end, one is going to be AHOH. Remember, that's water. And then the other one is lithium to high sulfate. Okay. Water is always indicated as L most of the time in these kind of scenarios. And the other one is going to be aqueous, meaning they're actually separated. Okay. Now we're almost there. This looks like we have predicted it, right? We got water, lithium sulfate. But the one other thing that you need to do here is that you need to balance the equation. So you see 2 lithium here, but you only see 1 lithium here, right? And you see 1 hydroxide here. You see 1 hydroxide here. That's great, but 1 hydrogen, but there's 2 hydrogen. So you try balancing this equation and come back. So coming back, we have 2 lithium hydroxide and 2 HOH. This indicates there's 2 hydrogens, 1 sulfate, 2 lithium, and 2 hydroxide, and 2 hydroxide. Now I'm going to rewrite the whole equation just to on the right-hand side, just to kind of give you a we wouldn't write 2HOH, right? So I'm going to rewrite this whole thing. So So let me rewrite it up here. H2SO4 aqueous plus 2 lithium hydroxide forming, don't forget the aqueous, forming lithium 2 SO4 aqueous plus 2, now not HOH but H2O liquid. This would be the better way in order for you to write the whole equation and predict the acid-base reaction. Now we're going to do a learning check based on what we have learned so far. So try this and come back and check the key. And here is the key.